Assalamualaikum and good day to everyone. We, Group 3 from FC2, will be presenting you a video entitled Synthesis of Ammonia and Reforming Reaction. So these are the names of our team members. Our team consists of 5 members with our leader, FATIHA SYUHADA. Hi, I'm NURIZZ, and I will be giving you a little introduction to our video and also a little bit of glimpse on what our video will be about. So our team were asked to explain all of the reactions involved in order to get ammonia. Next, how do chemical equilibrium concept relate to it? And lastly, to calculate the enthalpy of reforming reaction. So the introduction is that, how do we really get a synthesized ammonia? There are 2 things that we need. First is hydrogen, and the second and the last thing is nitrogen. It is simple as that. But how do we really get these reactants, which is nitrogen and also hydrogen? Well, the basic idea is that we can get the nitrogen from the natural air around us. However, hydrogen will be needed from the reforming reaction. Now that we have nitrogen and hydrogen, we can get the ammonia through a process called Haber process. However, I will not be explaining in detail on how these reactions occur. But now that you get the basic idea of how and what do we need to get ammonia through Haber process, well, stay tuned on how these reactions occur in detail from my fellow teammates. The objective that we want to achieve in this video is that, first, we want to study the reactions involved in order to get hydrogen through reforming reaction. Second, we want to study the reaction involved in order to get ammonia through Haber process. Thirdly, we want to study the concept of chemical equilibrium that are linked from all of these reactions. Fourth, and lastly, we want to study the steps on how to get the value of enthalpy of reforming reaction.
Next, we're gonna go through to chemical equilibrium concept. What must we know about chemical equilibrium? We must know that chemical equilibrium only occurs in a closed system, where the reaction is carried out in a sealed container and none of the reactants or products are lost. In chemical equilibrium, the rate of forward reaction is equal as the rate of reverse reaction. The result of this equilibrium is that the concentrations, pressure, and color of both reactants and the products are constant and do not change. The final equilibrium position is the same. What is equilibrium position? Equilibrium position is the point in a chemical reaction at which the concentration of reactants and the products are no longer changing. Since the rate of forward and reverse reaction are equal, we can conclude the final equilibrium position is also the same.
Moving on, the synthesis of ammonia through Haber process. Haber process is defined as an industrial process for producing ammonia from nitrogen and hydrogen using an ion catalyst at high temperature and pressure. Based on the equation, 1 mole of nitrogen will react with 3 mole of hydrogen to produce 2 mole of ammonia. It combines the nitrogen from the air with hydrogen derived mainly from natural gas such as methane into ammonia. The reaction is reversible and the production of ammonia is exothermic. Now, we're going to learn what happened in Haber process. Firstly, hydrogen is obtained from the reaction between methane and steam, producing carbon monoxide as a byproduct. The hydrogen produced from this reaction will also react with oxygen from the air to produce water and leaving nitrogen behind. These gases are then compressed and delivered to the reactor where ammonia is produced. These gases are then cooled down and ammonia will be liquefied. Unused hydrogen and nitrogen are recycled back to the reactor, so no reactants are wasted. However, we need to note that this is a reversible reaction and that the forward reaction is exothermic. The Haber process uses Le Chatelier's principle to maximize ammonia production while keeping production costs in mind. Since the forward reaction is exothermic, we may conduct this reaction at a low temperature. But why do the standardized temperature is set to 400 to 450 degrees Celsius? If a low temperature were used, the rate of reaction would be very slow, even though the exothermic reaction would be favored. Therefore, the compromised temperature will ensure that the reaction proceeds with sufficient yield. Based on Le Chatelier's principle, increasing the pressure will favor the site with fewer moles. Isn't it better to conduct the production at high pressure? So why do we only use the pressure of 200 atm? This is because it is expensive to build and operate a plant that can withstand such high pressure. And that is why 200 atm would be the ideal pressure for this particular reaction. Not just that, the presence of catalyst does not affect the position of equilibrium, but it increases the rate at which equilibrium is reached. In conclusion, Haber process is a process to produce ammonia from hydrogen and nitrogen. It is conducted at 400 to 450 degrees Celsius and at 200 atm in the presence of an ion catalyst.
Steam reforming or reforming reaction is a method for producing syn gas by reacting of hydrocarbons with water. Commonly, natural gas is the feedstock. The main purpose of this technology is hydrogen production. For catalyst, the reaction is using nickel and mina, and the temperature is within range of 800 degree to 900 degree at medium pressure of 20 until 30 bar. Thus, these three are the equations for the reforming reaction that will occur in the reactor. The first one, it will produce the carbon monoxide and hydrogen gas. It is endothermic reaction. The second one, it will react again to produce carbon dioxide and hydrogen gas. It is exothermic reaction. And the last one is endothermic reaction, and the reaction will give us carbon dioxide and hydrogen gas. This is called reformic reaction. Ta-da! Then we will see how the reaction will undergo. The first one is the natural gas such as methane or propane, and it will undergo desulfurization to absorb hydrogen sulfide, COS, sulfur adorant, or combination thereof at a selected temperature and pressure. After that, the purpose of pre-reforming is to break down higher hydrocarbons such as butane into methane, which allow for more efficient reforming downstream. Then, steam will release to react with the hydrocarbon in the reactor to form the hydrogen, and then will reform again to react with the same reactant. For the next step, which is shift conversion, which is the reaction of synthesis gas with the steam in a reaction to convert carbon monoxide into a raw gas mixture, including carbon dioxide and hydrogen. The last one, it will undergo pressure swing adsorption, which is a technique used to separate gases under pressure according to the species molecular characteristic and affinity for an absorbent material.
Next, we need to calculate the enthalpy of similar reforming reaction at 25 degrees Celsius. So given the chemical equation as shown in the slide. So to find the enthalpy, we need to find the summation of enthalpy formation of the products minus the summation of enthalpy formation of the reactants. So given the enthalpy formation for each compound in the table, so there is no enthalpy of formation for hydrogen gas, as hydrogen gas already in its element state. So to calculate the enthalpy, so the enthalpy formation of carbon monoxide minus the sum of enthalpy formation of H2O and CH4. So substitute the value, and finally we got the enthalpy is equals to 206.103 kilojoule per mole. As you can see, the enthalpy is positive, so it means this reforming reaction is an endothermic reaction, which means the heat is absorbed in the reaction.
Now that we are almost reaching to an end of our video, we can conclude that first, reforming reaction is needed in order to get hydrogen. Second, Haber process is needed to get synthesized ammonia. Thirdly, chemical equilibrium is related in all of these reactions, since these reactions are reversible reactions. Fourth and lastly, the value of enthalpy of reforming reaction is positive 206.103 kilojoule per mole, which is an endothermic reaction, and it absorbs heat, since the value is a positive value. So that's all from our group about chemical equilibrium concept in this video. Thank you.